This question is about amino acids R, CH, NH2, COOH. Part A. Table 17.1 shows the R groups for 4 amino acids. Part 1. In the boxes, draw the organic products for the reactions of stearine shown below. Let's first look at the reaction between stearine and H+. Like with hydrolysis, the NH2 group turns into an NH3+ group. However, the rest of the molecule remains the same, so the carboxylic acid remains the same and the OH group remains there. Now let's look at the reaction between stearine and CH3,2CHOH and sulfuric acid. So this is an esterification reaction, and we're going to form an ester link between our carboxylic acid group in stearine and the OH group in our reagent. The rest of the molecule will stay the same, and it's only this ester link we're going to form. When reacting stearine with CH3COCl, we're going to form an amide group, so our CH3CONH, that's our amide group, and we're also going to form an ester between our alcohol group on stearine and the CH3COCl group, or more accurately the carbonyl group in this acyl chloride. Now I'm just going to highlight the marking points of this question. So when reacting stearine with H+, and noticing that you form NH3+, this product gets you the mark. Having it fully correct will get you a mark. Then reacting stearine with CH3,2CHOH and sulfuric acid, having your ester link in your product and the rest of the product correct gets you the mark, or 1 mark. Then, when reacting stearine with excess CH3COCl, having the correct amide group formed and ester group formed, gets you 2 marks. So this product will get you 2 marks towards the 4 marks of this question. Part 2. A student is provided with one of the 4 amino acids in table 17.1. A student carries out a titration with a standard solution of hydrochloric acid to identify the amino acid. The student's method is outlined below. 1. The student dissolves 5.766 grams of the amino acid in water and makes the solution up to 250.0 centimeters cubed in a volumetric flask. Part 2. The student titrates this solution with 25.0 centimeters cubed of 0.150 moles per decimeter cubed of hydrochloric acid. Then part 3. 21.30 centimeters cubed of the amino acid solution were required for complete neutralization of the hydrochloric acid. Determine which amino acid the student used. Firstly, we need to highlight the key pieces of information in this question. Our first key piece of information is the mass of the amino acid in water that we're going to use to make up the solution. Our second key piece of information is the volume that we make the solution up to in the volumetric flask. Thirdly, the volume and concentration of hydrochloric acid that we use. We're going to use this information to work out the moles of hydrochloric acid we use in this titration. And fourthly, the volume of the amino acid solution that's required for complete neutralization of the hydrochloric acid. Firstly, working out the moles of hydrochloric acid used. We're going to use the equation triangle of N divided by V times C. N standing for moles, V standing for volume, and C standing for concentration. So using the information in the question, we're going to do volume times concentration. Volume will be 25 times 10 to the negative 3 because we're converting centimeters cubed into decimeters cubed. Then we're going to multiply this by the concentration, 0.15 moles per decimeter cubed. That gives us 3.75 times 10 to the negative 3 moles of hydrochloric acid. Now we're going to use these moles to work out the moles of the amino acid. In order to do this, we need to take our moles, 3.75 times 10 to the negative 3, and multiply them by 250 divided by 21.3. This is factoring in the amount of amino acid solution we're required to use, and dividing it by the total volume of the solution. Doing this gives us the moles of the amino acid. Those moles are 0.044 moles of amino acid. We're then going to use another equation triangle. We're going to use this equation triangle to work out the relative formula mass of the amino acid. This equation triangle is mass divided by moles times relative formula mass. So using the moles we've just calculated, we're going to do 5.766 divided by 0.044. The 5.766 is the mass of the amino acid we're using, and we dissolve in water to make up the solution. That gives us an RFM, or relative formula mass, of 131 for our amino acid. Using the general formula of an amino acid as RCHNH2COOH, which we get from part 1, we can then work out the R group using the relative formula mass. So we first need to do 131 minus 12 plus 1 plus 14 plus 2 plus 12 plus 16 times 2 plus 1. This is the relative formula mass of CHNH2COOH. That gives us 57. So then we need to match this 57 to the relative formula mass of one of the R groups. This matches the relative formula mass of the R group of leucine. So just to double check, that would be 12 plus 3 times 2 plus 12 plus 1 plus 12 plus 2. That equals 57. So that confirms that we're using leucine. So then we need to write as our answer that the amino acid is leucine. To get the marks for this question, you get 1 mark for working out the moles of hydrochloric acid, 1 mark for working out the moles of the amino acid, 1 mark for working out the relative formula mass of the amino acid, and then your final mark for identifying that the amino acid is leucine. Part B. The student is provided with another amino acid. The student attempts to identify the unknown amino acid using chromatography. The student obtains 2 TLC chromatograms of the unknown amino acid and the 4 amino acids in Table 17.1, using 2 different solvents, W and X. Part 1. What is the RF value of styrene, SER, in solvent W? When working out RF value, you need 2 values. You need the distance travelled by the solvent front and the distance travelled by your sample. So if we work out the distance travelled by the solvent front, that would be 2.6 centimetres. Then we're going to have the distance travelled by styrene, or SER. So using our ruler, we can see that that is 0.9. Then that gives us a value of 0.35, which is what we write on the answer line for this question. To get the mark for this question, you must have a value, or an RF value, of between 0.33 and 0.35. Part 2. Analyse the chromatograms to identify the unknown amino acid. Explain your reasoning. Firstly, look at solvent W. We can see that the chromatogram for the unknown amino acid matches that of leucine and glycine. So this is our first line of explanation, that it matches leucine and glycine in solvent W. Then we need to look at solvent X. Looking at solvent X, we can see that the chromatogram for the unknown amino acid matches that of alanine and glycine. So this is our second line of explanation. So, and matches alanine and glycine in solvent X. So that means our unknown amino acid is glycine. To get the marks for this question, you get your first mark for having the correct explanation and your second mark for correctly identifying the unknown amino acid, glycine.